Hello and welcome to a TypeScript tutorial. Yes, I promised you that, so we're gonna do that. I mean, this channel is for Solana stuff, but most of the time when we build something for Solana, we're using TypeScript actually. Because the on-chain development is just a tiny part of it. Most of it is the front end and the scripts that call the programs, and those are still mainly written in TypeScript with the Web3.js. And so my goal for this video is that you have a better understanding of how TypeScript works, such that you can more easily work with the Web3.js. This video is a perfect introduction for people who have never worked with TypeScript, but know programming from other languages like Python, Java, or wherever you come from. But it can also be a very helpful resource for people who already code in TypeScript, just to get even more familiar with the nuances that make that language what it is. A weird kind of complicated, I mean, not complicated in a sense of complicated, but like, I don't know how to describe it. It's like the weird little brother of the sophisticated programming languages that we have. That's how I feel about TypeScript. And really that brother is the son of JavaScript. Okay, here the family tree analogy gets really strange. Let's not get there. But basically what I want to do is go through a few things that are specific to TypeScript or JavaScript that you might have not encountered in other languages. And I hope that by the end of this video, you will have an easier time working with the Web3.js, especially the new Web3.js version 2, because that uses a lot of types and gets complicated. So that's why I make this video, teaching you one step at a time. Today, TypeScript. Now, TypeScript is JavaScript plus types. Who would have thought? So really when we're writing TypeScript, we're writing JavaScript. But how about I don't talk about it and I'll show you. Let's create ourselves a TypeScript script. Yeah, script.typescript. So as I mentioned, TypeScript is based on JavaScript. So basically any JavaScript code is also valid types. Well, almost. But you can take your JavaScript code and make it TypeScript. And you can also do the other way around by removing all the type annotations. Then you get from your TypeScript to JavaScript again. So in JavaScript, you would do something like defining a variable, freaking I don't know, or another variable. And JavaScript doesn't care about types. Everything is just a variable. I mean, internally it has types, but it doesn't enforce them at all. There's a word for it. JavaScript is weakly typed or untyped, whereas TypeScript is strongly typed. But there's still another word for that, dynamically versus statically typed. So JavaScript is weakly typed, as in it doesn't really do types. In TypeScript though, I can define types with this double point and then say what type it is. Here we have a number, make this a number, cool. And then TypeScript enforces that this is actually a number. And here, if I would say this is a number, TypeScript would be like, hold on a second. String is not assignable to number. You want a number and here it is a string. So you better make it a string, then I don't complain. So TypeScript is strongly typed. Every variable has its type. And if you don't define the type, TypeScript will still be like, oh, this is a number, because I can infer this from here. You don't need to specify it, but if TypeScript can't guess the type, then you will need to specify the type. Let me give you one example. So if I had a function f with a variable here, and this one is not typed, then TypeScript will complain depending on how you've set it. It will still infer any. This is the equivalent of no type has been set. It can be anything. And depending on how you run it, it might or might not complain. So if I do ts node and I run my script, then it actually complains unable to compile TypeScript because the variable implicitly has any type. Implicitly. For that to work, I need to explicitly say that yes, I want this to be any type, which in general, I don't recommend. If you ever use that, why the hell are you even using TypeScript? Don't do that unless you need to do a quick fix from something else that you didn't write. But if you write code, write it clean and and don't do that. But yeah, if I explicitly do it like that, then it will work and it will, print whatever variable I will put in here. But this is just not very clean. So preferably you would say, oh, I want this to be a string. And then TypeScript will stop me from putting in something else than a string. Like if this is a number is not assignable to string, so therefore it complains. I mean, you understand types. Other languages have types as well, so I think you get this. But I could now be like, oh, this variable here, I set it to a string. Now here it will complain that string is not a number because I defined it as a number. If we were in JavaScript, I could just do that. In fact, let's do that experiment. Let's do the same thing, but in JavaScript. The only thing that we can't do in JavaScript is those type annotations, because those are TypeScript. But if we remove those, then boom, we have the same thing in JavaScript, and that will work. Now I gotta run it with Node. Boom, I'm a string. It allows that. I can put in whatever here, because this is, besides it's weakly and dynamically typed. But TypeScript, on the other hand, is actually statically typed. It's strongly and statically typed, which means I cannot just change the type of the variable after it has been defined with a certain type, whether explicitly or implicitly. So even if I don't do it explicitly like this, the type of the variable is inferred here at definition. So if I want to allow something like that this variable can become a string, I can do cool stuff like, well, it's a number or a string. The or is with this straight line down. You might remember this as the Boolean or operator. So that's how you can say from the type it's that or that. There is also the AND operator. We will get to that in a second. So here now I say this variable can be a number or a string. Here I make it a string because it can be a string. It's allowed to be that. And then when I call it, funnily enough, TypeScript does do the check that at that point it is actually a string though. Because if I remove that, it will complain again because it knows that at this point variable is a number. So there are two different things. One, what you define it as, and two, what TypeScript actually knows about it. And TypeScript is quite smart, and that makes some things really interesting or really nice to code. For instance, let's say you have a variable that can be null. From the type it's, I don't know, a string or null. And we start out with null. Actually, it doesn't make sense if we start out with null. Let's make another function. Actually, our function. Let's say, because we can also define the return type of a function by saying here after the function definition, or what is that called? The function header, after this thing, before we open the curly brackets, we can also do that double point. And then here define the return type of this specific function. So we can say this guy returns a string or null. And then TypeScript will again complain, of course, that what we return here is neither a string nor null, because what we return is void. I could tell you about... Man, I'm gonna make this a 3-hour video if I go into everything. But just real quick, void, that's what you're used to from a function that doesn't return anything. Right? A function that doesn't return anything returns void. Any, we've already heard this, can be anything. So if I have any, I can return whatever I want, then it's fine. If I say void though, then I ensure that it doesn't return anything except for undefined. So anyway, getting back to our string or null, now TypeScript ensures that I return a string or null. So here I need to say something like return null, because the default is undefined, and undefined is not string or null. And we get to that in a second. So many things. So the can be null, let's say, is our function call. We call this function, and now what we get back is either a string or null. We don't know. At this point of writing the code, we don't know. Let's actually log the can be null. Yeah, so here TypeScript is not smart enough that it will tell me that this is for sure null, because it just got the type of this thing from this function where it got the definition here. it doesn't actually look what it would return. It's not smart enough that it says it only ever returns null, not within a function. But check this out. If I now do something like, hey, if that value that can be null is actually null, oh, I'm not in a function, I can't return. So, okay, let's quickly go into a function. I don't know, call it my main, whatever. Okay. I needed to copy this in here that within my main function, it now knows for sure again that that's a string. Because otherwise, if it just gets that, it doesn't have that info. So now it knows that's a string, and what comes back here is a string or null. So this is a string or null. So if I would do something like for sure not null is this thing, and I define that you're definitely a string and not null, it will complain, of course, because string or null is not a string, because it's a string or null. But TypeScript is super smart that if I have code here that says if it is null, I return, then it suddenly works. Because now TypeScript knows, oh, if it is null, then the path ends here. So after that point, this can be null must actually be a string, even though it was defined up here as string or null. Down here, it is for sure a string. And that's cool stuff that TypeScript does when checking the types. It can't get too complicated, but simple stuff like that, it will get it. And then we can work with this can be null as if it's for sure a string. Yeah, makes sense? Can follow so far? Good. Where do I go next? Because there are so many things. We have this thing to analyze, we have this thing to analyze, we have this thing to analyze. Maybe start with null. So you might know null from other languages like Java. Java has a null. That's the thing for when an object is not defined. It's an empty object that it's just not there. It's null. A null pointer. It points to the 0 address, indicating that it's invalid. That's how we know this from other languages. However, in TypeScript, we basically have two types for this, which is the undefined and the null. So there's undefined and null. What's the difference? But maybe before we discuss that, let's talk about JavaScript and how JavaScript is maybe just, chill in a way. It's like it doesn't take stuff too seriously. Show you what I mean. Let's do JavaScript script again. Let's say I had an object. Oh, by the way, in case you're not used to const and let, 2 words on that. With let, I define variables that I can change later. And with const, you define variables that cannot be changed. So mutable is 3, will work. Immutable is 4, will not work. Assignment to constant variable. And if we were in TypeScript, then we would already here see this by TypeScript telling us, hey, this is not possible. JavaScript will only fail if we actually run it. But anyway, so we have an object with fields in there. I mean, I can't teach you literally everything, but just for, completeness, an array will kind of look like this, where we have, individual elements in basically a list, and they don't need to be all of the same type. That works as well. So an array we would access with give me the first element. And an object is more like a map where you say object, I'm not creative right now. A is this, B is this, and C is this. So then I can say from the object, give me A. Or I can also say from the object access B. There you go. That's the same thing. Actually, let's do it the same thing. That is actually the same thing as that. And it will also give me, the same thing. So basically an object is some container that holds a bunch of variables or, can hold variables. And that's how we access them. Now, what happens if I access a part of the array that doesn't exist anymore? Or what happens if I access a part of the object that doesn't exist? Or like this. Then we will get undefined. That's JavaScript telling us that thing is not here. That you're trying to access something that is just not here. And also if I had something like I define a variable, but I never define it, guess what it is? undefined. Seems logical, right? So that's JavaScript's way of saying, hey, this just doesn't exist. It's not here. But note how this is slightly different than what I might want to express with null, where I say I explicitly want this to not exist or to not be defined. So I can say explicitly this variable should not be defined, and I set it to null, then it is type null. And even though I could set a value to undefined, this to me is kind of bad practice. Maybe in some use cases when you want to reset something that I would feel okay with it. But in general, you don't want to set something to undefined. At least not if you want to say that this is on purpose undefined. Undefined is more like it's never been here or it's not here anymore. Kind of meh, it's not here. But the null from the feeling is more like, oh, that's supposed to be like that. That's supposed to be defined as the value is not here on purpose. That's kind of the difference. I hope I explained that somewhat understandably. Or at least that's the difference for me. Like really, you can treat them the same way, of course. You can treat null as undefined and undefined as null. It's different types, but they don't mean the same thing. So if somebody familiar with JavaScript reads your code, they might get confused if you mix those up. Anyway, it is two different types. Let's continue here. Let's make a null variable. Actually, why do I make variables? Now, while we're talking about JavaScript, I want to mention another thing that people get wrong and that causes bugs. And that's the difference between this operator versus this operator. Usually we have it in an if, but for now I'll just log it. I want to see the result. As you would expect, undefined is not the same as null. And I can write undefined and null here. I don't need to have those variables. But see, most languages use the double equals for meaning this check. Is that the same? And now check that. This is suddenly true. Undefined is null, which also means that my two variables, if I compare them with this double equals, here this is suddenly true. And that's one of the reasons why TypeScript is weird. This double equals does type conversions. So it will try to convert types such that it can better compare. And there are some really weird things happening then. Because suddenly you can check, is 0 the same as null? Or is an empty string the same as null? TypeScript will say, no, this is not the same. Is it the same as undefined? No, it's also not the same as undefined. So obviously 0 will not be the same as an empty string. But wait, no, that's actually true. See, it's just, I mean, is it though? Is it though? But if I use 3 equals, then it's false, because then it doesn't do the type conversion. So this kind of is this empty check. This is empty, yeah, and this is empty too, yeah. So it's 0, yeah. Makes sense. I'll just convert this to the length of the string. Yeah, same, right? Same. But is 0 the same as 1? No, obviously not. Is 0 the same as 0 though? Yeah. Yeah, that is, sure. See what I mean? That's why JavaScript, without enforcing types, this stuff does type conversions. And it's just a bit, you know, can lead to unexpected behavior because it just behaves weirdly. And I also don't know all the details of how this type conversion works and what it sees as equal and what it doesn't see as equal. And guess what? We do have quite a few equal checks in our programs usually. So that can lead to very weird behavior. That's why it's good to do that stuff in TypeScript, because if we do that stuff in TypeScript, then TypeScript will complain. So for JavaScript, we had true. For TypeScript, I can't even run this because number and string have no overlap. This comparison appears to be unintentional because the types number and string have no overlap. TypeScript won't let you compare two different types, essentially. And what does it mean with no overlap? Well, what we had before. If I have the variable 1 here and variable 2 here, and I compare them, it will complain, this one is a number, this one is a string, I can say it explicitly, and those two have no overlap. They would have an overlap if, say, this one could also be a number. But again, TypeScript is too smart and will tell you that variable 2 is still at that point a string. So I would need to do a function like this, where TypeScript is then like, oh yeah, now it can be a number. Now it suddenly has an overlap because this could be a number, and then it has an overlap with this number, and then it knows how to compare. Yeah, this could be a number, and this could be a number, and if both are numbers, then we can compare them, and then it's fine. Now, I don't even know this, but what happens if we run this now? What do you think? Do we get true or do we get false? We actually get true. So the only thing TypeScript actually does is enforce the types, but it still keeps that behavior of doing the type conversion, which makes sense because really what it comes down to is just pure JavaScript in the end, and then JavaScript is interpreted. So even in TypeScript, I would recommend, just to make sure that you're not messing it up, to use the 3 equals operator, because that's really the one that you're used to from other languages. That does what other languages do with that. So basically, if you write TypeScript, you probably always want the 3 equals. And I'm not doing that either. Like, I'm so used to writing double equal that I never even have the idea to do that. But hey, we're here to learn some stuff. And I would recommend to myself and everybody else, if they're writing TypeScript, to use this one. Unless they want to have the type conversion from a string to a number. Which, you know, sometimes in TypeScript you want to have if you have user input that puts in as a string and then you compare it with a number. But see, that's why JavaScript is so, right? JavaScript is just such a language where bugs are just so easy to happen because it's just so, whatever. I take whatever. And if the function name doesn't exist, I just, you know, if it's undefined, then it's undefined, you know, whatever. I don't care. It's just, you know. Anyway, and one more thing to this. Sometimes we like to say if variable name to make sure that it exists. And also here, you need to be aware what it considers as true and what as false. Let's go through some examples. I really struggle to find the right word. So let's check, for instance, if I have a number, obviously, I would expect that this check succeeds because if 1, 2, 3, then success. However, if the number is 0, then if 0, JavaScript will be like, no, that fails. Because for numbers, if it's 0, then the if check is false. And usually we do the opposite. Usually we do if not variable, then return, something like that, right? But that's just the opposite of here. Flip the if and else around and you have the same thing. So check 1, 2, 3, check 0, check a string, but check the empty string. The string succeeds, the empty string fails. I mean, not so unexpected from what we tried here, right? And check null and check undefined, I would also expect to fail. Check an empty array. That succeeds, however. An empty array, if empty array, will still say, yeah, it's an empty array. And check an empty object, that also succeeds. You know, those things you just gotta know, such that you know what to expect if you have checks like these. Again, JavaScript is weird. But a point I'm trying to make here is that if you have a variable, let's bring it back to TypeScript, if you have a variable that can be a number or null or undefined or even a string, you know, whatever, you can do a check like if not my variable, then do something. And you will get here if it's 0 or undefined or null. So basically not a number other than 0. So if it's null, if it's 0, sorry, then it's not a number other than 0. If it's null, it's also just not a number. And also if it was undefined, then it's also not a number, and especially not one other than 0. Only if we have an actual number that we can actually use and it is not 0, then the script will go through and this will not be called. So yeah, in that way you can basically treat those two the same. Especially later when we talk about objects, you can check if it's null or undefined with this not my variable, and then handle the case where it's null or undefined. Okay, moving on. One more quick thing, just so you don't get confused if you see this. You know, we define a function like this, right? Function, function name, arguments. We could be like, you know, argument any. Function, function name, arguments, return type, and then the body of the function. There is a shorter way to write this. I can do the same thing by writing arguments, argument, any, and then this arrow, I can still define return type, and then this arrow, and then my function definition. This does the same as this, except I don't have a name for it, but I could inline this. And that's usually where we do this, you know, if we just use it once somewhere. I'm gonna take this and put it here instead of this name. And I will need to use brackets around. So here I define myself a function, and then I directly call that function. And here it complains again because now it knows that this is a string and not a string or a number. So to have the exact same thing, I would need this. Yeah, anyway, this is what I've always been doing in case you saw me write async function with 0 parameters that does this, and then I put that into brackets such that I can then call it. That's how I always start my script, such that I can use the async, that I'm in an async function, but I don't give it a name or I don't do anything with it, right? So it's the same thing here, except I don't do any argument, so I don't need to put in any argument here. Again, still same thing. Does that make sense? This shorthand definition, kind of a lambda, just so you've seen this. And while we're talking about functions and function names, I can give this function a name. Let me cut that out here and put it as a const. Well, same as this. I'm just gonna not use this. I'm gonna use get maybe number equals this. And boom, what we have here is a variable that actually holds a function. And that you might also not be used to from other languages. Now we can call it like we would, you know, it's just a normal function call. This doesn't look weird to you. If you know that this is a function, you call it. But what might look weird to you is that you define a function with this const as more like a variable. But yeah, this is now a function inside a variable. And also that has a type. If you look at it, the type is function to string and number. And I can in fact even explicitly type it to that. Then I define the type and then I define the function. So I wouldn't need to do this anymore actually. Because if I would return something else like null, then it would here again complain that the type mismatches. So the type from function with no arguments returning null is not assignable to a function with no arguments returning a string or number. And more specifically, null is not assignable to string or number. So this part is not assignable to this part. TypeScript helps you with that. And yeah, that sort of stuff you really need to know and understand if you want to work with a new Web3.js, because they do that a bunch. And actually, maybe I should show you where they do that. Let's do a new script. Let's do Web3.ts and import from Solana Web3.js. I'm gonna install that in version 2 though. Such that we get all the version 2 stuff, like those factories, most notably the send and confirm transaction factory. if I borrow that code again, because I like it so much, the send and confirm transaction factory itself is a function that returns a send and confirm transaction with blockhash lifetime factory. Oh, no, hold on. That thing here inside that object. And see, that's why this is so difficult to read sometimes. That object here is the send and blockchain defnet and a send and blockchain. You know, sometimes it's easier to go there and really have a look at the actual types. So this itself is a function. It takes first argument this object, which is of this type, and then here ends the arguments of the function, and the function returns this thing. It returns a send and confirm transaction with blockhash lifetime function, and they have named all of that to a separate type, and we can also look at that type. That itself is, oh, guess what? A function again. We see that here with the opening brackets. Opening brackets, first argument, type of first argument, and there we see the end. Oh yeah, we didn't discuss that yet. Then second argument with type, then third argument with implicit type, because that's 3 strings, and then end of arguments, that arrow thing to say, yes, this is a function, promise of void. So the return type of our function is a promise for void. What a promise is, basically the return type of an async function. So apparently we don't need to define at the type that it's async. So we see that this send and confirm transaction factory returns us this, which is a function. So if we actually call it like that, you know, with RPC and RPC subscription, then we get, let's call it send and confirm transaction, a function. This is now the send and confirm transaction with blockhash lifetime function that we can call with this transaction and this config. So point being, this is the same as here where we define a function, give it a name as this variable, and then we call it. And of course you can, if you make it mutable, redefine it for whatever reason. Then suddenly the function does something else. You can do that. Would I recommend that? I don't know, depends what you do. But then you can change what a callback would do or something like that. There are use cases for it. Anyway, boom. So I went through this defining a function. Where do we go next? I mean, objects, I already saw objects. That could be a good... I think I want to continue with the and, because we've already seen that just now. Let's talk about types with that and, or maybe even before that, type definitions, because we've also seen this here. Type, where you basically, like we did here, the string or number, I could define this as a type, because then I don't always need to type this. So I can say my type, string or number, is string or number. And boom, I've defined a type in TypeScript. And now I can use this thing instead of this thing and this thing. And that's what the new Web3.js does a lot, which sometimes makes it more difficult to read, because now suddenly here this is a string or number and I'm like, well, but what is that? So I need to, you know, step to the definition of that and then see, yeah, okay, it's that, and then that, oh yeah, okay, that's that. Okay, good. But let's have a look at more complicated types. And the end, I mean, obviously with the primitive data types, it doesn't make sense to have an end. I couldn't say string end number. I mean, I can say it, but would I ever manage to have that? Could I ever? I don't know what I put here. I mean, here it will complain. Number is not assignable to type never. Why never? Because it understands that this cannot work. It even understands it here. So it can never be a string and a number. It literally translates that here already to never. Wow, TypeScript is smart. So yeah, there's a type, never, which says this can never happen. So you can never assign anything to that type. Okay, so that doesn't make sense, but it will make sense with objects. So let's define myself object with number, or first, the simple way I define myself an object, and in here I say we have a number, and I don't know, whatever. This is an object of type object with number, which is a number. So I can define this type, object with number, as object with number, which is type number. Boom. And then I could even type this object with number as my object with number. Cool. I mean, so far so good. Now I could also define a type object with string, which takes string, and I don't need to, I can call this whatever, I just, same thing. I could create myself an object with string of type object with string, and then if I define it, it will already suggest to me that what we need here is that string, hello. And now, maybe it already makes sense for you to combine types. And we could again combine them like we did here. It's either the object with number or the object with string. But what we can also do is define a type object with number and string, which is of type object with number and of type object with string. Because here that will work. Here, when we want to do that object with number and string, and now you're wondering why the Web3.js v2 names are so long. Because they use speaking names, like I'm doing right now. If we have that type, then I just do an object that has a number and a string. Yo. And then that thing is an object with number and string, which contains those two things. And if you've worked with a new Web3.js, that should seem familiar to you, because that's how they build the transactions. If you add that, then you have a transaction with block hash lifetime, and then you have a fully signed transaction with block hash lifetime. It's all strictly typed. There you see it again. The transaction that it requires must be a fully signed transaction and a transaction with block hash lifetime. Those two types it requires for this transaction to allow that function to take it as an argument. So it helps you. It also makes it a bit more complicated to get the right object, but therefore you will already find out at compile time. What I'm saying is you can figure it out when you look at the code, not only when you run it. Yeah, anyway, that's what we're talking about here. Yeah, the objects with the end. And while we're here, let's look at another thing. Let's say I have a number and I want to put this in here. I would do this, right? However, here's the cool thing that you should know when you work with TypeScript or JavaScript. If you have a variable that already has the same name as the name of the field in the object, you can't just do this. And this will take this thing. It even highlights it. Look, same thing. Actually, I wouldn't recommend using that name in particular because that's also the exact name of the type, but TypeScript is smart enough that it distinguishes those. And then also if I call that the string, I could either do, that's the same thing. It will take that from here and put it in here. But even if I don't explicitly say that, this will still be that thing. Why? Because it has the same name. Just to avoid, those double saying number, double point, number, string, double point, string. And I don't mean for type definitions. Oh, wow, this is so confusing. I understand how you might get confused. This here is not a type definition. Here we don't define the type. Oh, wow, I'm getting how this could be super confusing for you. Because it also looks like a type definition. But no, maybe I shouldn't call them differently. I call them freaking N and S. N be my number and S be my string. Again, now those names are again confusing. It's not a type definition. N. It's just how JavaScript defines the elements inside an object. Like in JavaScript object notation. This is basically JSON. But my point here was, in order to not have to, double specify this, I can just do that. If it has the same variable name, then it will understand. Of course, if we have a different variable name here, then it will say, well, N is never declared. If you want that, then you need to say the n is the n1. But if we have the same name, then this is enough. And you can mix and match as we had here. One define like this and another one like this, or all like this, or none like this. But it also makes TypeScript code less readable. But again, we will need this in the new Web3.js, where most of the things we define the parameters in an object like this, because it's more flexible and we're free in the order of how we provide them and so on. So, I can provide the string before the number. No problem. That's the exact same thing. Okay, one more thing though. No. So that's how we do it with, variables into that object. Now, what if we have those two objects, the one with a number and the one with a string, and I now want to make myself an object with a number and string from both of them? So basically what I would need to do is my n is from the object with number, get me the n, and my s is from object with string, get me my s. This is how I would need to do this, right? Well, there's actually a nicer way how to do this. But for that, we go back to JavaScript and an array like this. Let's say I have an array 1, 2, 3, 4, 5, 6, array 1, array 2. And I want to create an array that contains 1, 2, 3, 4, 5, 6. But I don't want a double array like array 1 and array 2, because then I have an array inside an array and that's freaking annoying. Because, then we have this array. It's still those two arrays, just that we put an array on top. That's not what I wanted. I wanted one array with 1, 2, 3, 4, 5, 6, right? How do I do that? I can do that with a so-called flattening operator. Is it called that? I call it flattening operator. Basically what it does is it takes out the individual elements of this. So then we only have the 1, 2, 3, not the array anymore. And it would be the same as if I write this here with the commas. 1, 2, 3, 1, 2, 3. No array. That's the same. So if I do that, then suddenly I have it in one list. You might have seen this in the old Web3.js when we put in signers, at the transaction.sign, or here, for instance, when you add, instead of creating individual instructions, you could be like, my instructions are an empty list at first, and I could just add all of those things into my list of instructions or array, whatever you want to call that. So instead of all of those, I could now flatten my instructions, and that would work as well. There we would see that as an example. Also here with the signer, if I had a list of signers, which would be, this and that, then I could flatten my signers into here, giving me the signer comma min. So the several arguments into this function. I can also unflatten it into, and you see it here as well, into several arguments. We don't have that so much in the new Web3.js, because the new Web3.js, as I mentioned, prefers to define stuff. Here it prefers to define them as a list, and for other things, like it always tries to define stuff in those objects. Like even here, it's all inside objects. That's why we don't put in several things, several parameters. But yeah, speaking of objects, we were here discussing objects and how to do that better. Already have an idea? Because guess what? We can do the same with objects. We can flatten objects. Like this object with number, I can flatten it, and this object with string, I can also flatten it. What will happen if I do that? Well, it will take all of the fields inside this object and put them here, comma separated. As if I would write all of the fields of this object into here. In this case, we only have one per object, but if I wanted to make myself an object with string and number and boolean, then I could do so by flattening this object that I have up here with the n and the s that it got from the other ones, And then I add my boolean b, which is true, yo. And just to show you, if we print this object now, there we go, then we get the n, the s, and the b inside this one object. So the n and the s it got from here, and I added the b. And we have that in the web3.js. I'm gonna show you here because it's a proper script. For instance, for the block hash, I like to use this because the block hash will come back, the value will come back here as this block hash and last valid block height thing. If I confirm a transaction, it takes a transaction confirmation strategy. That thing takes the block hash and the last valid block height. And instead of, you know, saying block hash equals bh.blockhash and last valid block height bh last valid block height, and so on and so on and so on. Instead of all of that, I could just be like, flatten me the bh, and it's the exact same thing. Then I need the other stuff. This one is called signature though, so that's how I need to provide it. If I would call that, and we learned that, if I would call that signature, then I could do this. Simple. But my point was, this flattening is the same as this long thing. Man, I gotta move on. I still have a few things that I want to get through. And this video is long already. So this is the packing of objects. Let's talk about the opposite, unpacking them. So let's say we have this object with string and number and boolean, and I want to get the things out. Well, obviously, if I want to get my bool, I can be like, object with string and number and boolean dot b. Okay, cool. I mean, that will work, right? But then I will need to do that 3 times for my number and my string as well. I'm showing you how not to do this. This is a too long variable name and this is a too short variable name. Ideally, you would pick something in the middle, but also maybe not one that is the exact same as the type. Oh, by the way, speaking of types, except for the primitive types, which starts at lowercase letters, usually type names start with uppercase letters and the conventional camel case spelling as TypeScript uses. And then variable names, we again start with lowercase letters. Just another thing that you might not have known, but that make your code way more readable to other people who are used to that. Okay, anyway, so to unpack, I basically need those 3 lines of code, which there's a more efficient way. Of course there is. I can be like, hey, this is an object. Actually, let's start with a list again, because with a list, it's easier to understand. And then we put that onto the object. So let's say I had a list of my number, string, boolean. And the list I could unpack like this. I just say, hey, my number, my string, my bool, using them down there, is my list. So this is the other way around. Now we take the list and we unpack it into those variables. And to prove that that actually works, I'm gonna log you my string. There, hey. And that thing works, of course, not only if you have a variable here, but also if that was a function call returning such a list. And we have that, for instance, when we do, where did we do that? Do we do that somewhere here? There, at the find associated token PDA. That thing gives you a program-derived address. But what a program-derived address is, if you go to the actual definition, you see that it's a list of an address and the PDA bump, which is just fancy for a number. And we can unpack that here like I did here, because I do not need to specify all of the elements. I can leave the my bool out and that will also work. Even though I still have another element in my list, if I unpack it like this into my number and my string, I will still be able to get the string out. That also works. So I can ignore stuff. I can't ignore the first one because then obviously my string will suddenly be the number. So leave that in. Yeah, so obviously that can come from a function. And that's for lists. Now, back to my object. Instead of doing it so weird like this, I can comment it out already again. Guess how I'm gonna do that? Again, say const or let, depending on if I want it mutable or not. And then instead of the square brackets, I use the curly brackets because this is an object now. But here's the thing. Well, first let's go the easy way. Let's unpack it as n, s, and b from this object with string and number and bool. Oh, damn it, I'm redeclaring variables. Nah, well, change your names. Then that works. Then I can unpack that. I define it as new variables now because I have the const here. So that would unpack the number, the string, and the boolean into those because it knows that this object with string and number and bool has those three elements. That's how I can unpack them. Now, maybe I don't like those names and I would like to call them differently. Like, you know, here I was free to call them whatever. How would I do that? So I just say the n that comes from in here is now my number. Boom. And then I have a my number variable. Or the string that comes from in there is now my string. Or the boolean, my bool. And that now is the same as we have here. That's how we unpack this object. And again, we usually do this directly from a function call. You don't often see it unpacked from a variable, but from a function call. But you now know how that works. Because sometimes you read stuff like that and then you might be confused, and now hopefully you're not anymore. One more word about generics before I leave you. So there's also this thing with those sort of brackets. That's called generics, and it's yet another topic. Basically, it defines from that thing, it can have different types. Yeah, if you see stuff like that, that's the default RPC transport config of that type. So that's something in there, some type in there, so a static string that's in there, or a promise for a key pair. So promise is the type, but we can have a promise for a string, or a promise for a number, or a promise for something. Then we specify that in those, what do you even call those? Basically defining a new type with one type. So here, for instance, the address, you define the type of the address with another type, or here with those two types. Yeah, no, I don't want to rush the explanation of this. Okay, actually, I do want to rush the explanation of this. I can do this. Come on. In our typing here, for instance, I can make a type that depends on another type, and the T is the other type. And then I define that as, well, it just has, I don't know, an element T that is of type T. Okay? Cool. So now, for instance, I could do an object with number st that is of type depends on another type, and here I put a number. Then it creates me basically a copy of this, but replaces the t with number. So because this I put number, makes this to be a number, and then essentially it looks like this. Except that I have double types now. So basically, what I put in here as my t needs to be what? Well, you guessed it, a number. If that's not a number, then the type will complain because the t needs to be a number. Cool. But I can do that now with anything here in the generics. For instance, with another object, st. So for instance, my object with a string, boom. Put the object with a string as generics for this type. What do you need to put as the t? Well, not the number anymore, but guess what? An object with a string. Amazing. Then it works. And that's generics. And we have a bunch of those in the new Web3.js. Like a lot, like every address here is defined with generics, even with like the entire address. And it does get a bit complicated if you go deeper here. For defnet as a generic, because it comes from the defnet, it puts that into the type via generics. It does get complicated quickly here. But Yeah, man. Back to neutral. Hope that you learned something. In case you couldn't tell, I'm getting a bit impatient because I've been recording for 3 freaking hours. That took longer than expected. But I hope that it provides value to you and that you learned something about TypeScript and that you now have an easier time working with the Solana Web3.js, simply because knowing all of those things will make it easier to read the Web3.js and therefore also understand what all of those types mean, and then make it easier for you to use the right types, so find out what types you actually need. That was essentially my goal. Let me know if I succeeded in the comments. Like this video and subscribe if you have not done that yet. Keep telling you. And then you can watch some other videos. Here's one on the Web3.js. It just got released in version 2. Check that out or look at something else. And then I will see you in a future video. Good luck on your TypeScript journey and build all the nice Solana apps. Deps. Yeps. And I gonna go to my yoga class now, which I'm already late for. So see ya!